In this video, we're going to learn how to find vertical asymptotes. So again, when we're dealing with vertical asymptotes, and really the first half of everything we're talking about this week, we're talking about this with relationship to rational functions, which means I'm going to have a function that has probably, and maybe it won't be factored right away, but you might end up with some sort of polynomial as a numerator and as a denominator. And what we're going to look for is where we're going to have a vertical asymptote. A vertical asymptote is, of course, if I were to draw a coordinate plane, a vertical asymptote is a line that is dotted that you might see on a graph, or you might not see it. Sometimes they don't show it. And what it is it tells us as x approaches this point, and we'll call this point C. So as I get closer to C from the left side, and I'm just going to make up a function here. It is not the function that I've written. As I approach C from the left side, my graph is going up forever and ever and ever. So if I were looking at a vertical asymptote, that's what it does, is it says it's going to go up forever, but it's never going to actually cross this line. From the left, it's going to go down forever, perhaps. So this is a sample type of rational graph that you might see. And again, this C value, let's call it 3, would be that I now have a vertical asymptote on the line x equals 3. So because I'm using a line, just like an axis of symmetry, and what I'm looking for is determine the real numbers where the denominator is 0, but the numerator is non-zero. So let's take a look at what I mean by that on the next slide. So I'm going to look at this function, and the first thing I'm going to do is factor. So again, if you haven't mastered factoring yet, you really need to keep practicing because we're going to keep doing it. Let's go ahead and factor. The top doesn't need to be factored. The bottom, if I look at x squared minus 4x minus 5, I'm looking for numbers that multiply to 5, that subtract to 4. So I'm going to use negative 5 and positive 1, because negative 5 and positive 1 add up to negative 4 and multiply to negative 5. Can I cancel anything? No, I can't. So what this tells me is that when x minus 5 is equal to 0, x is 5, that is a vertical asymptote at x is 5. If I look at my other factor, x plus 1 equals 0, if I subtract 1, I get x equals negative 1. That is also a vertical asymptote. So if I were to graph this, which I have, take a look at x equals 5. Notice there is a dotted vertical line that goes through that. And at x equals negative 1, there's a dotted vertical line that goes through that. So what does that tell me? That it's impossible for me to plug in 5 or negative 1 because my denominator would equal 0. Now, you might be saying, hold on, you said something about the denominator equals 0, but the numerator does not. Well, let's take a look at our next example to see how things might be different. Here's my next example, and I'm going to start it the same way, by factoring. So I'm going to leave my x minus 3 on top. My denominator, I'm looking for numbers that multiply to negative 3 that subtract to negative 2. So I'm going to use negative 3 and positive 1 because those add to negative 2 and multiply to negative 3. Now I'm sure you've noticed these two factors will cancel out. So let's talk about the difference between an asymptote and a whole, because what I have from my last example is that if I take x plus 1 and set it equal to 0 and solve, I get x equals negative 1. That is a vertical asymptote. That's the equation of a line. But x minus 3 canceled with the numerator. So if it ends up as being something that canceled, then I'm going to have a whole at the point x equals 3, because if I set x minus 3 equal to 0, I get 3. So let me show you what that looks like on your graph. On your graph, x equals negative 1 is as we can see, an asymptote. X equals 3, and unfortunately Desmos doesn't show holes very well because they're so small, but essentially, if I were going to graph that, it would kind of just be an open circle, and I can't seem to get it right at the 3, but it would be an open circle at the 3, basically saying, if I plug in a 3, it doesn't work, but everything around that does work and has sort of a pattern to it. So there would be a little open circle right here at 3 that says there's a hole. But if it just asks for the vertical asymptote, that's this guy right here. Notice there's not a dotted line here at 3 because it's not an asymptote, it's just a hole. So one for you to try, find the vertical asymptote, if any, for this function. When you're done, press play to see how you did. So again, first thing I would do is factor, if possible. And looking at that denominator, x squared plus 25 doesn't factor because it's a plus in between. If it was a minus in between, it would be x minus 5x plus 5, as we know. But because it's a plus in between, that guy doesn't factor. So what does that tell me? Well, it tells me that there's not going to be any kind of vertical asymptote because it didn't factor, so there's not a number I could plug in for it to be 0. And I can see that by my graph as well. And you can also, if you don't believe me, you could also just set this equal to 0. We would see x squared equals negative 25, x equals plus or minus 5i. Those are imaginary. Again, no vertical asymptote because it's imaginary. And again, we can verify that by looking at the graph. There's no vertical dotted line anywhere, and therefore there is no vertical asymptote.